This question is about vector addition, and in this case you have an object that is supported by two strings, and you have two tensions, 1.3 newtons and 2 newtons. In part A, you are to find the resultant of these two tension forces. So we just do a vector addition, and I always like to sketch out the vectors I'm adding. So we are adding a 1.3 newtons a vector with a 2 newton vector in this respective direction to find out what is our answer, which is our resultant vector in part A. So when you're checking your answer, please check that you have an appropriate scale. You should ensure that this scale allows you to draw as big a vector diagram as possible. Maximize the diagram that you have, because the bigger the diagram, the smaller the chance of having errors. A bigger diagram masks the inaccuracies in your drawing better. So first up, check that you have a scale. Second thing, check that your diagram is as big as possible. If it's too small, you could have drawn it bigger by enlarging the scale. Then I will always start with a starting point, and I'll just draw the first vector to scale. So make sure that the length of the vector is measured accurately. And in this case, for my scale, this line should be 13 cm. And use a protractor, also measure the angle accurately. I'll continue on the vector diagram with the second vector again to scale. Be very particular about the angle measurement and the length of the vector, and you will therefore end the vector diagram at the ending point. The answer to this vector addition is the resultant vector, which is simply just connecting the starting point to the ending point. If you have done this accurately, you should get a resultant vector of 2.6 newtons and is exactly perpendicular to the horizontal. Now, in part B, you are asked to state the weight of the stone. When the question asks you to state, it means that the answer can be just written out immediately without much calculation. So the weight of the object is actually the same answer as part A, which is 2.6 newtons. Now, why is this so? The combination of the two outwards tension force results in a total outward force of 2.6 newtons that is pulling the stone outwards. Now, this outward force must be there to balance some downward force, which is the weight of the stone that's pulling it down. And we know that these forces are all balanced because the object, the stone, isn't moving, it's stationary, it's at equilibrium. So whatever outward force there is must be there to balance the downwards weight. If the total outward force amounts to 2.6 newtons as per your answer in part A, this will therefore mean that the downwards weight is also 2.6 newtons.